Analyze the conductivity of the solid. The unknown substance does not conduct electricity as a solid. In metallic solids, highly mobile valence electrons, often described as a sea of electrons, allow the solid to conduct electricity. Since this white crystalline solid is a non-conductor in its solid state, we can immediately eliminate any metallic elements, such as copper, Cu. Analyze the conductivity of the aqueous solution. The substance conducts electricity in an aqueous solution. To conduct electricity in water, a substance must be soluble and dissociate into free-moving charged particles, ions, that can carry an electric current. Ionic compounds, like NaOH, are strong electrolytes that dissociate into free ions in water and conduct electricity. Molecular compounds, like glucose, C6H12O6, dissolve as intact, neutral molecules and do not conduct electricity, non-electrolytes. Network covalent solids, like CO2, are completely insoluble in water and do not dissolve to form ions. Therefore, this property strongly points to an ionic compound, identifying option B as the prime candidate. Correlate with the melting point. 320 degrees Celsius, the substance melts at 320 degrees Celsius. Ionic compounds have moderately high to high melting points due to the strong electrostatic attractions, lattice energy, holding the ions in place. The melting point of sodium hydroxide, NaOH, is approximately 318 degrees Celsius, which is extremely close to 320 degrees Celsius. Molecular solids like glucose have much lower melting points, around 146 degrees Celsius, because they are held together by weaker intermolecular forces, like hydrogen bonding and dispersion forces, rather than chemical bonds. Network covalent solids like CO2 require breaking highly stable covalent bonds throughout a 3D network to melt, resulting in an extremely high melting point, over 1,700 degrees Celsius. This confirms that option B is the correct answer. The correct answer is option B, NaOH.